The objective today is to explain what the Intel manual says about pointer data types, and this video will be pretty short, just because this section is really short. And you know, when I first heard the word pointer, I didn't really realize that a pointer is just an address. But maybe you could say it's a special kind of address because it's pointing to a location in memory where data is, data that I assume you or the program, the program wants. And so that's the first sentence in this section, and we're on page 92 by the way. And if I was Intel, I'd just make it even simpler. I would just say pointers are addresses, period. Now they say in non-64-bit modes, the architecture defines two types of pointers. There's a near pointer and a far pointer. A near pointer is a 32-bit offset, also called an effective address. And this is within a segment. Near pointers are used for all memory references in a flat memory model, and I think flat memory model is the most common one, or for references in a segmented model where the identity of the segment being accessed is implied. And so when it says implied, I imagine that colon separated thing. So a softball question to begin, what are two types of pointers? I think this next one's a good question. Which type of pointer makes an effective address? And I say that because it just said here that a near pointer can be 32 or 16-bit offsets, and if we're talking offsets, now we're talking about effective addresses, because an offset calculation gives us an address. Now a far pointer is a logical address consisting of 16-bit segment selector and a 32-bit offset. Far pointers are used for memory references in a segmented memory model where the identity of a segment being accessed must be specified explicitly. So remember, the computer can implicitly decide an address, or the program can explicitly do that. So your next question is, what type is a logical address associated with? That is to say, a far pointer is a logical address. And what makes it logical is the segment selector combined with an offset. So if we're in the 16th segment with a 32 offset, we have ourselves a logical address. Oh, that makes a lot of sense then, a near versus far pointer. And I think there's a Star Trek episode, TNG episode called Something at Farpoint. But anyways, the diagram here is a pretty good one because as we can see, near pointers are smaller, only 32 bits, but a far pointer will need 32 bits plus 16 more bits to tell us what segment of memory we need to go to. Okay, so see why I said this will be a short video, because that's pretty simple. Now we're back to talking about 64-bit mode as opposed to 32-bit. This is after finishing a section about integers and floating point numbers and signed and unsigned integers. So it looks like there will be some nuances when we're talking about pointers in 30 or in 64-bit mode. And I don't remember seeing this before. The Intel manual says this 64-bit mode is a sub-mode of the 32-bit one. I'm wondering, has this always been the case? That's just some new lingo right there, sub-mode. But apparently in this 64-bit mode, a near pointer is going to be 64 bits, not 32. This equates to an effective address. Far pointers in 64-bit mode can be one of three forms, so wow, we have quite a few options here. And it looks like if we went with option A, that means a far pointer is also 64 bits, just like a near pointer is 64 bits. So my question is, in what scenario will both far and near pointers be 64 bits each? In the scenario when we are using 64-bit mode and we have a 16-bit segment selector and a 16-bit offset. So the last thing I'll say about this segment is we just have a lot more choices when it comes to pointers and we're using a 64-bit mode. I almost feel like this is death by choice because there's such a variety we can use. And I'm sure there's a purpose, maybe program performance, maybe something my primitive mind is not understanding yet. But here's one more question to finish out the day. It says, how big is the offset in a far pointer with a 16-bit segment selector and an operand size of 32? So I start by finding a far pointer on this diagram. So that's a near pointer. Here's a far one. Then it says with a 16-bit segment selector. So, okay, here's 16 bits. Here's another one. So it could be either of these so far. But the last clue says the operand needs to be 32. So where's the operand? Okay, so it looks like both of these have 32 bits in their operands. So this is a bad question because I need to know the size of the offset. Okay, so a much better question. How big is a pointer with an offset of 16 bits, a segment selector of 16 bits, and an operand, a size of 32 bits? And my answer would be 32 plus 16 and 16 is 64 bits. Okay, so thank you for watching and see you in the next one.